Hey all, I want to put together a quick video on how to set up printer settings in Bambu Studio for printing the various parts that make up the Svalboard. I've been using my Svalboard, which I assembled from a self-print kit for around a week now, and hope to help some others who are maybe a little bit less familiar with the advanced settings needed to get the parts printing clean enough for a working board. The first step is to get added to the Svalboard repo on GitHub. Morgan, the designer of the Svalboard, regularly sweeps through. It is a manual process, but does sweep through and gets users added to both the supporter channel in the Discord and grant access to the GitHub repo, which contains all of the model files. A note on what version to use. We are going to be solely within the slightly FDM folder, but a note on what version to use. At this point, it's generally recommended to use the v1.3 RC version, but most of the files you'll be seeing in this example come from the v1.2, since that is where I got the files for my board. As a part of the building process, you will want to reference the Svalboard self-print guide, currently on Google Sheets. It'll tell you how many of each model you do need to print off, and it's also important to note that there are different sized finger keys, and you want to make sure that you print off the fingertip sizer PDF file here so that you can get the correct file. That way the keys actually fit your fingers. Going back to the self-print guide, the key plate slide shows custom settings for both PLA and ABS. I will only be covering PLA, but the location of the config settings are going to be the same for ABS. Another important detail I want to call out is that the settings I'm about to show in Bambu Studio work for all of the keys except for the tipping center keys, which have additional settings needed. Alright, so I've gone ahead and brought in a key file. The only really important thing is to make sure it's flat. The backs of the keys that face outward on the cluster are flat on the bottom, and the biggest thing is you want to make sure that the flag on the key model itself is facing upward, and that applies for all of the keys that you print off. So in the case of normal keys, there's only 3 settings you need to change. Under quality, in this case under global objects, quality, the layer height needs to be changed to 0.12 millimeters. The initial layer height needs to be changed to 0.18 millimeters. And there's something referenced called exterior perimeter. And in Bambu Studio, that is the outer wall under the line width setting. So you want to change outer wall to 0.3 millimeters. Once those settings have been applied, you'll be good to print off as many keys as you need. So for the tipping center keys, we're actually going to start with default settings. And when I bring the file in, you can see that it's actually on edge. So what we want to do is you can either click the auto orient button, which in our case happens to lay it flat, or you can click the R key, see which plane you need to rotate it in this case the Y axis. We can set the Y to either 90 or 270, hit enter, and see that the key is laying flat on its side. Since this key is off the ground or off the print bed a little bit, we do need to make sure that supports are enabled. In the example photo from Bambu Studio on the slides, I believe that normal auto was selected for the type of support. In my case, I printed with tree and experienced no quality issues, but if you do run into quality issues, maybe try with the opposite option. The important thing to note here is that we do want to change the base pattern spacing to a very, very low option. So if we go down under support to advanced, there is a base pattern spacing that's currently defaulted to 2.5 millimeters, and we want to change that all the way down to something like 0.1 or 0.2 millimeters. Now that the base pattern spacing has been changed to 0.1 or 0.2 millimeters, you can print as many of these keys as needed. For the palm rests and carriers, I've gone ahead and brought in these files, and we are going to go ahead and do that in a new project. with default settings. There are a couple settings that we need to set, but the first thing we want to do is actually get these oriented in the correct position. If you look at the carriers, you'll see that they're actually a little bit off of the build plate. So I'm going to go ahead and auto orient those so that they lay flat. Again, you want to make sure that the parts that raise up are facing upward and the flat part is on the top of the build plate. For the palm rests, you want to rotate them to be on the flat side. So I'm going to go ahead and click on each one of these individually, press R, and rotate. Make sure I'm working in the right direction. In this case, I see 316, so I know that I'm going to change the left one to 270, and I'm going to change my right one to 90 degrees. For the palm rests, I noticed that setting to 90 degrees isn't exactly where they need to be at. If you go ahead and click on the left and right palm rest and click auto orient, you'll see that they actually change by 5 degrees. So the left palm rest for me changed to 275 and the right palm rest changed to 95. This will actually ensure that they're sitting flush on the build plate. You can also move them a little bit closer together to save on filament. Using Bambu Studio, at this point, you're good to print off both the palm rests and the carriers. The slides explicitly call out tree support. In this case, Bambu Studio actually defaults those both to being the correct setting, and it also calls out a setting under the Others tab called Brim, which is under bed adhesion, and you can see is by default set to auto. And we can verify that this is working by clicking the Slice Plate button and checking that there is this blue brim around the base of the model. At this point, we're ready to go ahead and start working with the objects that are a little bit more complicated or involved to print. I've gone ahead and created a new project and brought in both the base plates and case models. What we're going to want to go ahead and do is worry about just one hand at a time. So I'm going to go ahead and, if you go over from the Global tab to the Objects tab, you can select both the Case Right and Base Plate Right and delete them. Now that we're working with just one hand, we can go ahead and right-click here, go down to Split, and Two Objects. We can pan our view down just a little bit, make sure that either neither or only one is selected, and then move one object off the top of the other object. In this case, this is actually the bottom of the plate, or the bottom of the case. And so you can go ahead and click that and then click the auto orient button to make sure it's laying flat on the build plate. The top half we actually need to rotate, so we can go ahead and click R and change the Y value here to 180 degrees. You're also going to want to make sure that your model here is fully within the bounds of the build plate. At this point, we can go ahead and start setting the custom settings we need for the case and plates. By default, we already have the 0.2 layer height set, but we do need to set the number of wall loops by going over to Strength and setting the wall loops from 2 to 6. We also need to go down to Bridge Direction and change it from 0 degrees to 180. This next section is probably the most complicated or most involved part of printing off the Svalboard. We do need to go into specifically the Objects tab and to the base plate, right-click it, click Add Modifier, and select Cube. Now that you have a cube, you want to select the cube on the left-hand side, go to Strength, scroll all the way down to the Bridge Direction, and you want to ensure that it is matching what is currently shown on the Svalboard self-print build guide. In our case, I'm going to put this cube in the top left-hand corner of this case, and so I need to have it set to 135 degrees. Now that we have a cube, we can go ahead and move this up to the top left-hand corner. By selecting on the left here, we can actually hit Control-C and V twice to duplicate this. Go ahead and move one to the right-hand side and one to the middle. Make sure to update the bridge direction under the strength for each of these cubes individually. In the case of the one in the middle, it needs to be 90 degrees, and in the top right, needs to be 45 degrees. Now that all 3 cubes are placed on the base plate, we can go ahead and resize it by clicking on one, clicking the S key, and using the red and green squares to manipulate the size of them. For the left base plate, I've gone ahead and made my cubes the size needed to adjust the bridging angle. In this case, the top left is approximately 62 by 50 by 50 millimeters. The top right, 56 by 50 by 50 millimeters. And the middle cube, 124 by 42 by 26 millimeters. The only thing left to do now is to go back over to Global and disable supports. At this point, you're ready to print. For the clusters, I've gone ahead and created a new project, and we're going to want to start by laying these down on the flat side. So we're going to go ahead and select them all, hit the R key, and rotate on the Y-axis by 180 degrees. To get the thumb clusters to more closely resemble what's on the self-print guide, you can actually rotate these on the Z-axis by 180 degrees. You can move them down and then individually move the parts closer together. There's a couple of project-wide settings that we can change. We do want to make sure that under quality, our layer height is set to 0.2. However, we do want to go all the way down to wall generator and select arachne. We also want to go to the supports tab and ensure that enable support is unchecked. Under strength, we want to go down to the bottom and change bridge direction to 180 degrees. Now that we have our global project settings set up, we can go ahead and go over to the Objects tab, right-click on one of our step files, go down to Add Modifier, and select Cube. For the thumb clusters, we're going to want a total of 4 of these cubes. While you don't need to change the size of the cubes for the thumb cluster, you do want to make sure that they are correctly placed over each of the holes for the keys. You also need to make sure that the angles are exactly correct. In my case, I have the right thumb cluster on the left-hand side. On the top left, I have the bridging direction set to 152.7 degrees. On the bottom left, the bridge direction set to 166.2 degrees. For the left thumb cluster on the right hand side, at the top, the bridge direction is set to 202.8 degrees, and at the bottom right, 193.8 degrees. For the finger clusters, the process is a little bit easier. We want to make sure that we go ahead and click on one of the finger cluster models, right-click, and add a modifier of a cube. In this case, we want to actually resize the cube by hitting the S key and making it the same width as the holes for the keys. Specifically the top and bottom keys. We now want to make sure that the generic cube is selected on the left-hand side, go down to Strength, and change the bridge direction to 90 degrees. Once this is done, we can copy and paste the key cluster as many times as needed. You should now be good to print off the clusters. While the regular 44mm size trackball holder is available in the GitHub repo, to download one with a shim or that supports a different size trackball, you'll need to download it from the Onshape repo. To access the Svalboard Onshape repo, you can go over to svalboard.com/trackball-repo. An important note is that in order to view the newest branch or other versions, you'll need to create an account and login. In this case, as of right now, the recommended version is the B3 variable bearing height branch. Once here, we want to go over to Svalboard 3.175mm static, and then change the configuration to the desired version. The version I'm currently using is the 44mm 2-slot 60/60/80. At this point, you can skip ahead if you don't want to make any custom changes, but if you do, you're going to want to click the Make a Copy to Edit button. Go to Owned by Me and create a public document. This will take a moment to copy. Once it's finished copying, ensure that you still have Svalboard 3.175mm static selected at the bottom, have the correct configuration selected, and if you want to make changes, you can go under Setup and Variables and change settings like the shim height. I personally use 5mm instead of 0.5mm. When happy with the changes, you can right-click at the bottom, click Export, ensure that step file is set as the format, and download is selected as the option. Again, this will take a minute. Back in Bambu Studio with our exported file, we can see that there's a bunch of extra things that we don't want, like screws and an outline of the PCB. So we can go over into Objects and select everything under our modified file, except for holder and cover, and then click the delete button. This will bring us to a clean printable version, which is equivalent to the file that you'd find in the repo without the shim. Once we're to this point, thankfully printing off the actual trackball holders is fairly simple. We want to ensure the layer height is the default 0.2mm, that supports are disabled, and under strength, the wall loops is set to 6. You should now be able to print. When it comes to assembly, I'd highly recommend Beat Builds a Thing's video on building the Svalboard. He goes step by step and provides plenty of detail. If there's anything I missed, I'll be sure to add it to the description, so be sure to check there. I also have to give a shout out to all the people who are involved with building the Svalboard. I believe it to be an excellent keyboard, and I'm looking forward to using it in the future. Thanks for watching.